we have talked about a few colligative properties already. So the freezing point depression, the boiling point elevation, then the vapor pressure lowering, and the last one is osmotic pressure. Okay. Before we get to the osmotic pressure, I have to explain this: the diffusion of water through semi-permeable membrane. Let me define the semi-permeable membrane real quick. Right. So the semi-permeable membrane has a really small hole. Only water can pass through. Anything else that bigger than water cannot. Water is really small, man, really small, so it can pass through things easily. Okay, so I'm putting this semi-permeable membrane right here. All right, so the rate of water going from A to B and B back to A are equal, so they exchange water all the time. All right, now here's what happened. I'm going to add salt again, adding salt into a compartment B. So what's going to happen is our two words for you, so two technical terms: hypotonic solution, the solution that have lower in concentration, and the hypertonic solution, you can guess, has higher concentration, or concentration of whatever we talk about. In this case, sodium hydroxide. So compartment B has a hypertonic solution, and in compartment A is a hypotonic solution. Okay, when the concentration of one compartment is higher than the other, well, and they are connected. Of course, this is a stress, right? So everything in this world have to go back to equilibrium. Normally, the sodium chloride will pass through will migrate from compartment B to A. That's what it normally do. But right now it cannot, because we have this semi-permeable membrane blocking it. Right? So there's a stress right here, high concentration and low concentration. Of course, that's not gonna stay that long. This is stress, right? So water is the only thing that can pass through. So what the rate of water going through from A to B will be higher than the rate of water from B to A. And we're gonna end up with the water level in compartment B higher. Okay, and all right, so we have the word for you. So osmosis is the flow of solvent molecules through semi-permeable membrane, not just flow. The flow of solvent we just call diffusion, but through semi-permeable membrane, the semi-permeable membrane is called osmosis, right? From lower concentration, hypotonic, to a higher concentration, so hypertonic. So we call osmosis. So there's an osmosis in A. It's faster than osmosis from B to A. Yeah, A to B is faster than B to A. Right? Now, if this keep happening, so well, the water level in B gonna be higher because more osmosis from A to B is faster, right? But as the water level in compartment B is higher, well, it started to get heavy, right? When the water level is higher and higher, the weight of water height in compartment B is pushed backward, right? And as the water is going up, the water in B push backwards. So the rate of migration, the rate of osmosis from A to B is slower and slower until it stops. Okay, so go slower until it stops. The pressure from B push back to A and stop osmosis we call osmotic pressure. The pressure applied across semi-permeable membrane to cease osmosis. Okay, so osmosis A to B go from left to right. The osmotic pressure, it looks like going down, but actually it go push back the osmosis, so we go that direction. Okay, that's the direction of osmotic pressure. In this class, we don't have to calculate the extent of osmotic pressure, right, in ATM or whatever. But you should be able to identify or specify where is the direction of osmotic pressure. Let's do it together on the next video.